All right, today we're going to be introduced to polar coordinates. Polar coordinates are a way of describing points that are not in our Cartesian one where we have x, y. So in polar coordinates, we have two things. We have r and theta. To get to those, we need to first know what O is. O is called a pole. So you always have a point you start with, kind of like the origin in Cartesian coordinates. Um, and that pole is where we draw everything from. So the line drawn horizontally, that's this way, is called the polar axis. So that's the polar axis heading horizontally that way, to the right. Any point P then in the plane, so like at this point up here, can be defined by its polar coordinates, r comma theta, where r is the distance from the pole. So r is how long this blue line is right here. That's r. And theta is the angle measured counterclockwise from the polar axis. So whatever this angle is measured from the polar axis up to that line, that would be our theta. And so the point is listed as an r theta. So for example, let's say we measured this line, this blue line, and it measured out to be 8. Let's say it's 8 units. We also measured this angle. We took a compass and measured this angle to be pi over 6 radians. Well, then we would list this point up here then would be the point 8 comma pi over 6, and that would describe the location to get there. So if you had a compass and a ruler, you could measure that out by starting with the horizontal polar axis, measuring the angle, and then measuring out 8 units. We extend this meaning of polar coordinates in the case where r is negative. So anytime that r is negative, it's going to lie on the same line through that same pole at a distance of the absolute value of r, but in the opposite direction. So what we mean by that, here we have this point up here, r theta. If we had the point negative r theta, we would take that same distance, so whatever this distance r is here, we would measure that same distance in the opposite direction this way, like 180 degree difference that way. That would be negative r. And so the point down here then would be called negative r theta. Another way we could describe that same point would be to take and add 180 degrees, or most times in polar we're going to be in radians. So remember, pi radians is the same as 180 degrees. And so if we added pi, or 180 degrees, to the angle, that would also bring us to the same point. So this would also be the same point down here. Another way we could describe that point would be r comma theta plus pi, and that would bring us to that same point. So there's different ways we can represent the same point in polar form. All right, the next thing we're going to look at is plotting points when the polar coordinates are given. So if you want to plot out these points, what we're going to do first is figure out where that angle's taking us, and then measure out that far with the r value from the pole. So we would start with some kind of graph here. Let's do A first here. We're starting with a graph. Here's our pole of 0. 5 pi over 4, that's an angle that is going to be more than 180, because 5 pi over 4 is bigger than 1 pi. And figure out where that is. If you're not good at estimating with radians, remember we could convert here. 5 pi over 4, we could convert to degrees by doing pi over 180 and simplifying. And that would simplify out to be here 225. So 225, that's one, if we minus 180 from that, there's going to be an additional 45. So that angle, it would be taking us all the way here. Okay, so now what you would do then is that's like 225 degrees or 5 pi over 4. Now we're going to measure out 1. So whatever 1 unit would be, let's say that that right there is 1 unit. So we would measure out a line the exact same length right here. And then that point where this is 1, that would be the point 1, 5 pi over 4. There's another example of that picture. All right, let's try another one here. The next one we have 2, 3 pi. So we want to draw another coordinate axis here. Start with the angle 3 pi. Well, remember, we know if we go around the circle once, if we travel around the circle once, that would be 2 pi. If we continue on and do another pi, that would take us right to the x-axis in the negative side there. So that's the angle. And then again, we would see, okay, how much is 2? Let's say 2 is that much. So we would want to measure that line the same distance out in the other direction. 1, 2. And that would be where our point is. So that would be the point right there of 2, 3 pi. Here's another picture showing you that same thing. All right, the third one here, this one has a negative angle. So if the angle is negative, we would do the same thing we did with unit circle back when you learned that. Now we're going to travel clockwise. So we'd want to travel clockwise 2 pi over 3. Let's do a little converting again. 2 pi over 3 times 180 over pi. That would be the same as pi's cancel here. 3 would go into the 60 times, so it'd be the same as 120 degrees. So if we traveled 120 degrees, that's 90 and then 30 more. That's where our angle would be. And then we'd want to measure out, again, how much is 2? So if that's 1, let's say that's 2. We'd want to measure out that same distance, which might be about there. There's where our point is. Here's again another look at that spot there. All right, last one here. This one has an angle of 3 pi over 4. If you convert that into degrees, that's going to be 135 degrees. So that's like a 45-degree angle here in quadrant 2. All right, so that's our angle. And then our pole here is -3. So whatever amount 3 would be, like let's say we had 1, 2, 3 on there. If we traveled that direction out here, that would be the point +3 pi over 4. But we have a negative. So remember, we want to travel in the opposite direction here, down this way. That same amount, that would be -3 pi over 4. So that's where our point is. And again, here's another view of that, so you can see there. All right. Final thing here. In the Cartesian coordinate system, every point only has one representation. But in polar coordinate system, each point has many representations. For instance, the point 1, 5 pi over 4, which we just graphed a little bit ago, shown over here, this one, could also be represented by instead traveling in the negative angle direction. So negative 3 pi over 4 would take us to that same spot. So these two are equivalent points. You could also travel multiple times around the circle. So here, this angle 13 pi over 4, the coterminal, that was a term we talked about in trig, the coterminal angle to that, the angle between 0 and 2 pi, is 5 pi over 4. And so that would take us to the exact same spot. We'd just be going around the circle one time before we came back to that same location. So that would be the same. One other way that we've talked about, if we just traveled the pi over 4 degrees, shown here, that would be the point right here, right there, of positive 1 pi over 4. But if we would make that negative, we'd move in the opposite direction. It'd take us right back again to that same location. So there's 4 different ways of describing the exact same location. So you can see there's multiple ways in polar to represent the same point.